All right, let's dive right in. Today, we are talking about a property of water that is absolutely essential for so many industrial processes, but it's often overlooked. We're talking about alkalinity.
So, let me start with a little bit of a puzzle. Have you ever seen this happen? You take a drop of acid, put it in one water sample, and the pH just tanks? But then, you add that exact same drop to another sample, and, well, pretty much nothing happens. What's going on? What's protecting that second glass of water?
Well, that hidden strength, that protective quality, that's alkalinity. It's the secret ingredient that makes all the difference, and that's exactly what we're going to break down today.
So what is this hidden strength really? Let's get right to the definition and figure out what's happening on a chemical level.
Okay, so technically speaking, alkalinity is just the water's ability to neutralize acid. You can think of it as a measure of its buffering power, how well it can resist a change in pH when you introduce something acidic.
And this is probably the best way to visualize it. Just think of alkalinity as the water's built-in shield. It's a defense mechanism that's always there, ready to protect the pH from an acid attack. It's a simple idea, but it's incredibly powerful.
So where does this shield even come from? Well, it's created by different compounds that are dissolved in the water. We're talking mainly about bicarbonates, carbonates, and sometimes hydroxides. These little ions are your frontline soldiers, just waiting to neutralize any incoming acid.
Okay, that's the science part. But to really get it, let's see it in action. This little tale of two waters is going to make it all click, I promise.
So, picture 2 glasses of water. In the first one, you've got pure distilled water. No buffer, no shield, nothing. You add just 1 drop of acid and bam, the pH plummets from a neutral 7 all the way down to an acidic 3. Now, look at the second glass. This one's filled with river water, and it's full of those bicarbonates we just talked about. You add the exact same drop of acid, and the pH barely even budges. That right there is the shield at work.
So, in a nutshell, that's what alkalinity does. It's like a shock absorber for the water's pH. It just soaks up the impact from acids and prevents those huge sudden swings.
Okay, so why should you care about this outside of a cool science experiment? Well, in an industrial plant, managing this shock absorber is absolutely critical. It's crucial for your operations, and let's be honest, it's crucial for your budget.
And this is where it gets really interesting. See, high alkalinity isn't just good or bad. It totally depends on what we're using the water for. In boiler feed water, too much of it can cause some pretty nasty foaming and carryover, which can damage your turbines. In cooling towers, it leads to scaling, those hard calcium carbonate deposits that kill your heat transfer efficiency. But then, you look at drinking water. In that case, a certain amount of alkalinity is actually a good thing. It helps form a protective layer inside pipes to stop them from corroding.
So the big takeaway here, it's all about balance. The real key isn't just knowing the alkalinity level, it's actively managing it and keeping it in that sweet spot for your specific system.
So what is that sweet spot? Well, for typical drinking water, you're usually looking for a range between 50 and 150 milligrams per liter. And by the way, when you see that measurement, it's almost always expressed as calcium carbonate. It's just a universal yardstick so that everyone's on the same page. This range is just right, high enough to stop corrosion, but low enough to avoid scaling.
And there are definitely upper limits for a reason. For instance, the Indian standard for drinking water says total alkalinity really shouldn't go over 200 milligrams per liter. Once you get past that point, you're pretty much just asking for trouble, inviting scale to form and cause all kinds of problems downstream.
And trust me, those problems can get expensive. If you're using a reverse osmosis system, or RO, high alkalinity is a total nightmare. As the water gets pushed through that membrane, all those bicarbonate ions get concentrated, and they start to form scale right on the membrane surface. This basically chokes your whole system, making you use more energy, more chemicals, and it just drives your operating costs through the roof.
So what do you do about it? Well, one common way to control it is with something called a high-rate solid contact clarifier, or HRSCC. Basically, it's a big tank where you add lime to the water. The lime reacts with the bicarbonates and turns them into solids, which you can then just remove. It's a pretty direct way to knock down both hardness and that extra alkalinity before it can cause any real damage.
All right, let's wrap this up. What's the one thing you really need to remember from all this?
At the end of the day, alkalinity isn't just some number on a lab report. You can really think of it as the backbone of your water. It's what gives it stability, strength, and resilience. It's that silent hero working in the background to stabilize pH, control corrosion, and prevent scaling. Understanding it, and more importantly, managing it, is just fundamental to good water treatment.
So I'll leave you with this question to think about. Do you know what alkalinity level you're maintaining in your plants? And have you ever had those persistent, annoying issues with your RO or boiler that might just trace back to this hidden strength in your water? It's definitely something worth looking into. Thanks for tuning in.